Hello guys, and welcome to a series of lessons when I can try to show you how to work with Pyro. And it's a very powerful tool inside of Houdini for creating different kind of volumetric stuff, volumetric simulation. And this lesson will be useful for beginners who want to understand how Pyro works. So there's a lot of different type of information you need to understand how to apply this information, how to convert this information to properly work. Because many of beginners just try to use the Pyro FX shelf to create like a presets, and they just try to understand how it's work, what nodes we need to add here, and how we can apply our source for getting result, how we can import our information for cache and render out. So in this lesson, I want to show you how to create all from scratch and how to apply different fields, what is the fields, how we can create them, how we can convert them, and etc, etc. So let's begin with that. I just want to add from the standard geometry. Now let's call it smoke source. So we begin with the smoke because fire is a little bit difficult for understanding because there is a lot of different fields we can use. There is a lot of different setups. We will go to the fire, but we begin with the smoke. And we're starting with the source because we need to understand how we can create our source. Like in real world, always, if you want to have a smoke or if you want to have a fire, you need to get a source. It's going to be logs, it can be some kind of fuel, oil, something. We can ignite and we have a fire, we have a smoke, and etc. So, and like in real world, over here in Houdini, we need to add a source. So better start with a simple geometry, add a sphere and convert it to polygon to better understand what is going on here. And the first thing we need to deal with is convert our geometry into the volumetric information, because for now this geometry is just a bunch of points connected with primitives, and it's looking like a volume because we, when we try to understand what this, we can say, okay, this is a sphere. Like in real world, we have a ball or balloon or something like that. It's filled with something. It has a volume, it has mass, density, I don't know, dozens of different physical properties. But inside of 3D, all what we have is just a bunch of points with some attributes and nothing more. So no volumes, no mass, no any physical attributes. All right, so we need to convert this geometry into the volume. So you can say, okay, what is the volume inside of our program? And volume is voxels. What is voxels? Each image you saw created with the pixels. So now I'm looking on the white circle, like the sphere on the 2D version. And I look in alpha channel and we can see that we have some information inside of this object, inside of the circle and outside. So black outside, white inside, we have some transparency here on the edges. And that's how we can apply some information. We use a pixel, so it's like small boxes here. They are 2D, they have just X and Y dimensions, and they represent the whole image. So it's like a volume here, but in 2 dimensions. And we create a volumetric pixels, we create the voxels. So they created by the boxes, not as squares, boxes. So we can simply draw it. We have a square, okay, this is pixel, and that's how we create a voxels. Because we work with 3D, we have a 3-dimensional space. We have the X, Y, and Z axis. And now we need to represent this sphere with the voxels. And it works like Lego bricks, when you can try to create something from bricks, from small boxes. And the smaller those boxes, the more accurate result you're going to have. The bigger boxes, well, it's not such good because we have a nice angle, we have a nice corners, yeah, big corners. So how we can convert this 3D object into the volume? Well, we can do this by different ways and using different nodes, but the most common stuff, if you want to quickly create some volumetric, we can go to ISO offset. So ISO offset allow us to create a fog volume. So it's not looking like a voxels, it's more looking like a spheres, okay? and it's way bigger than our sphere we use it, okay? And the reason for that, each time when you convert into some different type of information, you need to define the quality of this information. As I said, the lower size of the voxel, the more representative this object will be. So now we have the subsampling division, uniform sampling division. If you go to image, we can see that we divide our sphere into 10 subdivisions. And that's why we have just 1000 voxels, and the side of each voxel is 0.28. So that's pretty huge voxels, and that's why our volumetric sphere is way different from our source. So now if you go to our sampling division and increase that number to 100, now we can see the way better representation of our sphere. So now we have more than, we have 1 million voxel, and the size is 10 times smaller here. So it's 0.0208, all right? So what we create, and this field is showing for us like a fog. So we have a fog volume here output, we can either surface, grade, but in our case, I'm interested in either for fog volume because that's what we exactly want to use as my source. It's a field. So again, if you back to our image, we have like here, like an alpha channel. So each image has the channels, the red channel, green channel, blue channel, and can we have an alpha channel? So this like a field inside of 2D image. Each field will be a separate channel. So if we have the alpha channel, we have some settings here. So you can see that this image contains from 4 different channels, 4 different fields. We can call it a red field, green field, blue field, and alpha field. So our alpha field have one value out inside of the object and 0 outside of object. And here on the side of object, if you want to have a nice smooth edges, we need to apply some anti-aliasing, we need to apply some feathering here to convert our field information to the background. This means that each of those pixels will lose this intensity or scale, and it became more transparent, and now it's going to 0. So the same stuff is here. We have inside of this object have a fillet voxels with some value of 1. So if you want to name this field, okay, if you go here on information, we can see that this field doesn't have a name, so it's named like a 0. So we can call it, let's call it smoke. All right. So now we have a bunch of different voxels. We have a 1 million voxels, and we fill those voxels with some information, with some float values. And inside of this sphere, each voxel have a value 1 for the smoke field, and outside have a value 0. And on the sides, like in alpha channel, we have some different setups from 0 to 1. So it's pretty simple, okay? Except of channels, we have fields, and except of pixels, we have voxels. So just let's switch it to the 3-dimensional setup, all right? And it can help you to understand how it works. So it doesn't have any point cloud anymore like we did with the geometry. So it's a different type of information. It's like a parallel world. It can exist in one context, but we can't, connect our points to this because it's different setup, it's different type of information. All right, so what we can do with this density field, how we can use this as a source for our simulation. Okay, so we have a few different setups over here. So this field we can use as a source, okay, because now we converted this into the volumes, and we can go to null object and set it source out. So we can use this information to get a simulation. So we can use this smoke field for getting a smoke actually. How we can do this? Let's go into the DOP network. So our DOP network can create simulation. So now all we create is just some object. It doesn't move anywhere. It doesn't have any properties, settings. It just has some setup over here. So we can, I don't know, look on some information, memory usage and such stuff. And we have some amount of voxels. That's what we have. Nothing more. No advection, no any movement, no simulation. So to make a sim, we go into the DOP network. So our DOP network allows us to create any kind of simulation inside of Houdini. It doesn't matter, it can be RBD simulation, it can be flip simulation, it can be smoke simulation, fire, all stuff you can put inside of your DOP network. Particles. So inside of this network, you can see that now at dynamic level. So we had geometry, we have an object, and now we dive deeper and deeper. So you can see there we have a third level, and it's dynamic. So what we have is an output node allows us to define what information we want to out from my DOP network, but it's empty and I need to define what nodes I want to add here. So if we work with Pyro, I definitely want to add a Pyro solver. So it's like a main engine which allows us to create a simulation. You can connect it to output, and you can see that we have a bunch of inputs and one required. So all those input can be used by your or not, but this input is required because this is like an object you want to use inside of your simulation. And this object should be a smoke, not a smoke object. So smoke object is like a container when you can set up your smoke simulation, when you can set up, not a simulation, your smoke properties. You can find the division size here, you can find the creation, where you want to start a creation, work with instancing, and we can define a visualization, some initial data, fill, slice, and other stuff. So it's like a container for your smoke. And we can connect this to the object input. So now we have this container. The size of your container, you can define here the size in the center. We can deal with this a little bit later. But we don't have any kind of smoke here. If we play simulation, we can see nothing here. So there's no smoke inside of my box, but we had, but we had a smoke over here. We have a sphere and it's pretty big. Why we can use it? The thing is, we have the last connection, which call it sourcing. So we need to put a source over here. And as a source object for the main volumetric simulation, we can use a volume source. Volume source is a node which can set us, okay, where is my source? Okay, and what field I want to use for my source. We have a bunch of initialize setups here. We can use it for the smoke, for the fuel, flip simulation, it's liquid, collisions, pump, and etc, etc, etc. So we will go deeper in of those settings a little bit later. Now I want to explain how to work with those three nice nodes. So before you go into setup, we need to select my source and get it to the simulation. So the first thing I want to choose here is the soul path. So there's a few ways you can add it. If you use the different levels, like this dynamic swap can be somewhere here, and you need to link it. In many cases, you can use just press here, choose operator, and inside of my object, smoke source, choose my source out. Sometimes you can use just a simple local, so you can type that I want to use the upper level and choose the source out from a list. So we can do that. Or if we have a connection to the first input of my DOP network, we can apply a simple expression which is called op input path. And what we need to add here is just in quotes, select this node we use for now and the first input, so if input 0. But we still don't have nothing. Can switch between the wireframe mode. Sometimes if you are on the wireframe mode, you can see that we can't see the fields in the wireframe mode. They look like boxes, but we can't see them. So sometimes if you can see some simulation setup, you just need to check here what you're looking for. So you better look on your non-wireframe mode. Okay, so you do that, go to DOP network. Okay, so box is here, but we don't have any kind of fields over there because we don't have an operation. The volume source don't know what I want to put here inside of my Pyro solver, and I want to put my fields. So let's press plus here, And we have the first field we have to add to my simulation. And the source volume, we know that we have a field called smoke. And there is two types of field, is source volume and target field. And we have a bunch of different fields which Pyro is used for simulation. If you go here to smoke object, we can see them all. The density, temperature, fuel, divergence, burn, heat, velocity, collision, sourcing, etc. So those fields you can use for simulation. And the density field is our smoke. So if you have a density field in your simulation, you need to understand that this is smoke. So Pyro Solver want to have the density field if you want to work with the smoke. So that's how we can say, okay, I want to get my smoke field and put the smoke into the density field. So now Pyro Solver knows what exactly field I want to use for simulation. And when I play, you can see that we have something interesting. I don't know what, it's more like a columns. Fill it here. And the first reason, well, why we don't have a simulation first frame, because by default in smoke object, in creation frame, we have the solve and creation frame unchecked. And the reason for that, if you have a huge, hard simulation, heavy simulation, there's a lot of voxels. Sometimes when your simulation is freezing or something, you can, reset all this stuff and get to frame where is no, million voxels. So by default, we're not creating simulation on the solve frame. So we have a solve frame 1 and there is no any sim. But in my case, the simulation is pretty fast, so I can enable that. And now we have our simulation and a fast frame. Reason why we have like a fillet box and not a sphere, reason for that is our sphere is much bigger than box. So by default, if you go to sphere, we have just one, it's radius. So we have a diameter like 2. That's why I want to create my container a little bit bigger. Let's think 3, 3, and 3. So now we have something more or less productive. And again, we have something wrong because in the source, we have a nice sphere with a lot of voxels. But inside of DOP network, we have again a huge incorrect sphere with a huge amount of voxel size. A reason for that, we have a division size inside of our smoke object. So now we can apply a different type of settings to avoid any, incorrect result from the source to my simulation. All right, so if we want to link this parameter, so sometimes it's very helpful when we link our division size inside of my simulation to the source. So we can transfer the size of my voxel to the source to have a better matching. But if you go here, if you go to our ISO offset, we see that there is no division size. We have the number of sampling divisions. So we don't have a voxel size, we have just sampling. So that's why if you want to convert your geometry into the volumetric information for the Pyro simulation, I prefer to use the VDB from polygon node. So VDB from particles and polygons nodes allow us to create a volumetric fields depending on the source. If we have a particles, we can create a field from particles. If you have a geometry, in our case a sphere, polygon sphere, we create it from polygons. So now when I connect it to the sphere, we can see that we have a sphere created from the boxes. And this is like a hard surface because we don't have a fog, we have like real boxes here. And the reason for that, because by default, we have the distance VDB, which is create a surface. Sometimes it's helpful if you want to create some collisions for DOP simulations. But in my case, I want to create a fog VDB, so I enable that stuff. And now we can see that we have the voxel size, and it's 0.1 by default. If you go to information, and you can see that we already create the density field. Okay, so by default, the name of your field is density. It doesn't matter how you call your source field. So inside of volume source, we can see that we have the smoke like a source volume field, and we convert it as a density. So you can add a name whatever you want. So we can go here to our VDB from polygons and create the same smoke, all right, and connect this to our source out. This means that we're going to use this field again, and it should work. If we go down inside of our simulation, now it's working. But anyway, I just show you that we can create different fields names, but what I recommend to you is always create the proper name field. So we can call it density, and that's why we can always, you know, try to find the proper field over here. So that's much faster when you know, just working fast and you try to understand, okay, what is the name I field add here. So you always, if you want to work with density, if you want to work with smoke, you call it density, and that's it. So any type of field you create for the sourcing, if you create it for the smoke, you type density. And that's much faster, and we can avoid any errors because you can, you know, type anything you want, but you need to understand that any mistakes can just break your simulation. So we have a density here field here and connected to the DOP simulation. So now what I want to do, I want to connect my division size from the solver to my source. So I copy parameter, get here to VDB from polygons, and here on my voxel size paste relative references. Okay, so now we have the size 0.1 for the smoke and inside of my simulation. So each time when I want to increase my amount of voxel, if I play like 0.05, it will automatically change the voxel size over here. So it will match always the voxel size inside of your source and inside of a simulation. All right, so now we have like 33,000 voxel. That's not too much, but I think it's kind of good for our fast simulation. We can keep it and make it a little bit bigger later. So now if you look at our sim, it's my box, this is my container 333, and if I play simulation, there's nothing happen. In fact, you can see that the density increasing because we have a less transparent area. You can see that more and more dense. It became more dense. Why it's happened? Get back to volume source. Inside of volume source, we have not just a source and target field. We have also the type of operation you want to use for that and the scale of this operation. So by default, for all float areas, for all float fields, we have an operation add. What does it mean? In each frame or in each subframe, we grab the all fields, in my case density, from my source and put into your simulation. And in the next frame, we again take the same fields and put in my simulation. We add those fields. So now for those fields which has like a setting value 1 inside of the sphere, in the next frame, we add another one field, so it should be 2, 3, 4, etc. So that's why this sphere became more dense. We put more and more density inside of the same voxels here. All right, but it doesn't move. So if you want to create simulation for the smoke, we need to have some movement. The smoke is rising up, but it's staying here in this position. So how we can create an advection? Let's find out.